Hi guys, this is Manishar. So in this video, I am gonna talk about additional linked list operations like reversing of a singly linked list and inserting a node at a particular index in the linked list and the sorting of a singly linked list. So this video will be very interesting. So please watch this video till the end. So let's get started. So coming to the first operation, that is reversing of a singly linked list. So for example, if you have a linked list like this, 1, 2, 3, 4, 5, 6. So after reversing of this linked list, it will look like this. So it will look like this, that is 6, 5, 4, 3, 2, 1. So let's go to the code and understand this code line by line. So let's go to the code. So first, so we have written the function for this, the reversing of a linked list. So reverse linked list, it is a function name and it is takes the parameter, the header node of a type or node. And for the reversing of a linked list, we have using the 3 pointers, that is the previous and it is initially null and it is a type of node and the current and it is initialized to the header, that is to the first node in the linked list. And the next pointer, it is initially the null and it's a type of node. So we have to move to the till the end of the linked list. So therefore, we have to give this condition, that is while current not equal to null. So this condition moves till the end of the linked list. So first we have to initialize the next to the current of next. So next to the current of next. So next, the current of next becomes the previous and the previous becomes the current and the current becomes next. So current becomes the next. So after we have to change the header pointer, that is the head becomes the previous and we have to return the new head, that is a type of node. Therefore the return type is node. So let us trace this program first, then you will understand it clearly. So initially, so the head is pointing here. So I will take it as a head H and so according to the code, the current is pointing to the head also. And so the next big is and the next is null initially. And the previous P, I will represent it as a P. The previous P is also null. Okay, the previous P is also null. So first we have while current not equals to null. So the current not equals to null. So therefore we have to move the next to the current of next. So current, so that is, so current, so this is current of next is equal to current of next is equal to next. So therefore the next will comes here. So therefore the null pointer it will erase. So I will erase this null. So in now the next is pointing to the current of next and the next line is the current of next becomes previous, that is the current of next. So current of next becomes previous. So that is it becomes the null. What is previous here? Null. So that is this arrow will points now here. Will points here. So next we have to assign, we have to make previous is equal to current. So therefore the previous comes here. So next we have to make the current is equal to 8. Current is equal to next. So current comes here. So I will erase all others. So first iteration. So in the first iteration, it will looks like this. So this for one iteration. So next again it will checks the while condition. So current of next. So that is so current of next, that is not is equal to null. So current not equal to null. Therefore the current not equals to null. Therefore we have to move to the we have to move the next to the current of next. Therefore the next will point to the here current of next. So I will erase this next. So I will erase this next. And so we have to point the current of, so this current of next. Current of next is equal to previous. That is this, it will point to this node. So it will point to this node and we have to make the previous as the current. Previous is equal to current, and we have to make the current as next. So current will comes here. So again, it will while loop continues. The current not equals to null. So the condition is true. So the next we have to move the next. So the next will comes here, and again the previous. So current of next, current of. So this is current of next. It will point to the previous node. So previous, that is here this node, and we have to move the previous to the current. So previous will points here, previous is equal to current, and we have to move the current to the next, that is current is equal to next. So this will point here. So this loop will contains until the current is equal to null. So after doing all the iterations, so after doing all these iterations, so previous will point here, and the current also is pointing here. The next pointer will be equal to null. So the next pointer will be equal to null, and we have to make the header node as here previous. So head is equal to previous. So we have to display with the header node first in the linked list. Therefore, we have to point this header node here to the previous, and so we have to return that new header node, that is after reversing of a linked list. So this is about the reversing of a linked list. So coming to the next operation, that is the insert at a particular index, that is the insertion of a node at a particular index. So for example, if you have a linked list like this, so 1 2 3 4 5 6 7, and 1 2 3 4 5 6 7, and assume that we are having the indexes for each node, that is 1 for 0 2 1 3 2 and 3 4 and 5. So if I want to insert at the particular index of a new node, so uh, so after inserting at a particular index, the linked list look like this. So if I want to insert at the index 3, so then the linked list look like this, and the index will look like this: 0 1 2 3 4 5 4 5 6. So let's go to the code and understand this line by line. So coming to the code, so insert at index, it is a function name, and it will takes the parameters head, it is a type of node, and the int of index, that is it will takes the index, it is a type of integer, and the value, it is a type of int. So the value to be inserted. So for insertion, we have a prepared node with us, that is in the new node. So and I have allocating the memory for that with the help of a dynamic allocated function, that is the malloc. And I will set. So after this preparation of a new node, so this new node look like this. So it will mainly have two fields, the data. So that data is that value v, and the pointer to the next node, that is this is pointing to null. So this is our new node. This is our new node. So this new of data is initialized to value, and the new of next is initialized to null. So for example, if index double equals to 0 means what? So for example, if the user enters the index is 0, so that is here. So that is we have already know that insertion at the beginning. So we have to insert that node at the beginning. That is new node of next is equal to head. So new node of next is equal to head. So this will point to that first node, and so the head is equal to new node. So the head will comes here. So head will points here, and will return the newly updated head. So if the user does not enters any index is 0, so that is else part. So else part means we have to go to that index, and we have to insert that value. So that is we have taking the help of a pointer called as the temp. So that is initialized to head initially. So for this for loop is used to reach that particular index. So we have, so for I is equal to 0, I less than, so I less than index minus 1, I plus plus. So that is if a user enters, so the value 3. So if a user want to insert that the index 3 means, so this for loop will run So 0, 1, 2, 3 times. That is, so 3 node previous this uh, previous node, it will point to this node. So that is the previous. So the temp will point here. So the temp will point to that index -1. That is the second index the temp is pointing here. So the next we have to check the if temp is null or not. So if temp becomes null, so we know that the index is out of bounds. So then there is no use of the new node. So we have to free that new node and we will return that head. So then next we have to move the temp. So else if temp is not equal to null means we have to insert that at index. So therefore new node of next is equal to temp of next, and temp of next is equal to new node, and return that header node. So for example, so if a user want to insert the here index 4 is inserted at the position 3 at the index 3. So 4, so it is initialized to null, and this is the new node. So this is the new node. First, so first condition, if index is equal to 0, the user had entered the index 3. So 3 double equals to 0, false. So therefore this condition occurs, that is so we have to move to that index, that is so index -1. So we are taking the help of a pointer temp. So the temp will point to that previous node. So index previous node, that is here. So the temp will point here. And so next condition, next is the new node of next is equal to temp of next. New node of next. So new node of next is equal to temp of next. So that is this node will point here. So new node of next is equal to temp of next. Then next this node will point to here. Will points to here. That is the temp of next is equal to new node. So the temp of next is equal to new node. So it will points here. So then this index becomes 3. Then the indexes will be updated automatically. So then after the inserting at the index 3, so the linked list will look like this: 1, 2, 3, 4, 5, 6. So we can insert at any index. So I thought this code will be very simple. So I hope you guys understand this. So this is about the insert at the particular index.
So, hello everyone, my name is Sagar and my USN is 4JN23CS126. So we are explaining about list manipulations enhancing in linked list operation. So let us see. Before going to that, we have to know that what is linked list. So linked list is nothing but a non-linear data type. Sorry, linear data type. So the representation is simple. First of all, it is a combination of linear nodes only, which consist of a data and address of next node. And this is a simple representation of a linked list, and at the end it is terminated by null. Okay, this will be explained by my friend Manish. So let us go to my topic. This is a reverse linked list. How can you reverse linked list? And this is code for it. This is index at index. This is code for it. Right. Okay. This is a search in linked list which will be done by Manish R. And this is my topic. Sort a link. How can we sort a linked list? See, you have given this linked list, and how can we sort means, see, 5 3, we have given a linked list which is unsorted. In the let us see, 5 3 2 4 1 6 7. So after sorted, we will get this linked list, that is 1 2 3 4 5 6. And aim is that we have to sort in ascending order, means small to big. Let us see that code. See, I have written only main function in code blocks. We will run this, and there we can see all the main function including. Okay, so here void sorted linked, the name of the function sort linked list, and we are passing head. Okay, from main function we are passing head, and it's accepting head. So here, if head is null, we have to print empty linked list because we can't sort only. If we don't have the empty linked list means we can't sort. So here temporary pointer node of type node. This is temporary pointer of type node, and this is integer temp to store. Sorry, to sort it. Okay, so let us put one for loop. Current is equal to head. Current not equal to null. Current is equal to current of next, and another for loop. See, we have to put two for loops. Okay. For array also we will put two for loop, and here also we have to put two for loop. For next is equal to current of next node not equal to null, and next node is equal to next node of next. Okay. If current data is greater than next node means if current data is greater than next node data means we have to sort it. Okay. So with the using of temporary pointers like temp means we are considering int means so we'll just sort the data. After this, similarly, this occurs and sorted sorted linked list. So let us run that in code logs. So this is actually code. This is normal header files. We have to include it. So this is structure. We are declaring linked list using structure, and this is create node function, and this is inserted end means this is normal easy topics, and this is how we can print the linked list. This is this is the main. Okay, this is main function. Let us first run this program. Okay, see, my original linked list was 5281 and null, but after sorted will get 1258 means we are sorting in ascending order. So this is actually code. You can just copy this and you can paste it, or you can it's actually easy. Okay, it's like a normal array you're sorting, so like that one. You can So let us go to next. This is how we can sort. So this is remove nth node from the end. See now and it's actually we can solve this in two ways. Okay. So first of all, you can first method is to reverse this linked list. Okay. You have to reverse this linked list and you can remove that n node from the end. But another problem solving is like using two pointer approach. So let us see that also. See here, void remove nth node from this is actually function. Remove nth node from the end. It's actually function. Okay. So this is we will create first of all dummy node so that in original node we can't modify it. Okay. So that's why. And dummy of next is equal to head. We will use this dummy node. Okay. I said no two pointer approach. This is so first and second. This is actually code. Let us run this in code. Same, you can just copy it and paste it this and also same. Create node and insert at the end. Same to same all. And this is actually main function. Main function means it's not main function. Main linked list main function. Okay. This is let us run it. See, my original array was 1, 2, 3, 4, 5 and null. But after removing second node, okay, I'm considering second node means this is first node, this is second node. From the end, you have to consider from the end, and it has been removed. You can see, and let us go to next. Remove duplicates from a sorted array. Okay, with how sorry sorted linked list. Okay, see you have given this linked list. So you can see 1, 2, 3, 3 here repeated two times. 4, 5 it is repeated two times. See how can we remove this? Let us see. After removing this, we will get this 1, 2, 3, 4, and you can see here null. Null is the presence of linked list. Let us. So this is actually code. Okay. Sorry. Okay. this is actually code what remove duplicates. See, it's actually easy, okay? We have created dummy. See how why we are creating dummy means so that we can't modify original. Original will remain original. Okay? And this is actually code. Int I is equal to 0. I should here I have used two pointers, first and second. And I is equal to 0. I should be less than or equal to n I plus plus. If first is equal to null means there is no link node only. So we have to print linked list is empty, and else it should go next and next. Okay. After that, we will if first of next is equal to not equal to null means first is equal to first of next and second is equal to second of next. So this is actually the code. Let us run this in for blocks. See, before my original linked list was this. Okay, 1 2 2 3 4 4 5. Okay, this was my original linked list. But after removing duplicates, duplicates means replica. See here, 2 has repeated 2 times, 4 has repeated 2 times. So we have to remove that. After removing that duplicates, we will get the final answer is 1 2 3 4 5, and it is terminated by null at the end. Okay, so that's all about the linked list operations. Okay, so thank you.